Hi guys, I'm going to be solving this question on heterogeneous reactions, and the first question says that for a steady state linear first order heterogeneous reaction, write an expression to represent the overall resistance to reaction and define each term in one expression. Now, first thing I'm going to say first is that when you're dealing with heterogeneous reaction, there are two major rates you should be concerned with. We have the rate of mass transfer and we have the rate of reaction itself. Now I'll tell you the reason why the rate of mass transfer is coming in, and the rate of reaction, everybody knows that in every chemical reaction you have the rate at which the reaction occurs. Now for the rate of mass transfer, in heterogeneous reaction there are two things occurring. Do not forget it's two-phase. You have solid and liquid, you can have solid and gas, anyone. Now because it's a two-phase reaction, I have solid and something reacting together to give you the product. Now the rate at which that reaction is occurring depends on the rate of reaction, fine, that's rate at which product is formed. But do not forget that before the product is formed, there will be a transfer of liquid to the solid particles. If for example this is a solid particle and I need it to react with fluid inside this particular vessel, now the rate of this reaction, heterogeneous reaction, is the rate at which the reaction itself is occurring. Rate of reaction means that rate at which product is formed from this reactant. And the rate of mass transfer, there is a mass transfer because you have a solid mass here, so there will be transfer of mass from the solid to the liquid or from the liquid to the solid. That's just the concept why you have rate of mass transfer and rate of reaction for heterogeneous reaction. Now after understanding that aspect, let's go back to what the reaction asks us to find. You are told that write an expression to represent the overall resistance to reaction. Now this question is a very short derivation, but I want to use it to explain heterogeneous reaction from the beginning. Now for the rate of mass transfer, I have that Qg is equals to Kg into bracket Cg minus Cs. Now I told you for mass transfer, it's transferring from gaseous to solid particle, so you'll be having a change in concentration, and Kg here is mass transfer coefficient. That's just how this formula was brought about. Now for the rate of reaction, which is represented as Qs, I have Qs is equals to Ks Cs. Now at steady state, at steady state, Ss means steady state in this place. So at steady state, Qg is equals to Qs. Now steady state means at equilibrium. That's at the point where the rate of the reaction is steady with time. At steady state, at equilibrium, when nothing is changing, nothing is happening again, everything is already at the steady state. At that point, the rate at which the liquid particles will be transferring to the solid particles is equals to the rate at which the product will be formed. So that means as there's mass transfer between the solid and the liquid, at that same time you'll be having product being formed, rate of reaction. So at steady state, Qg is equals to Qs. Now that is settled. I can then say that Kg into bracket Cg minus Cs is equals to Ks Cs. Okay, so I can say Kg Cg minus Kg Cs is equals to Ks Cs. So let's bring those that have Cs together. Okay, so I have that Kg Cs plus Ks Cs is equals to Kg Cg. Okay, so I can then say that Cs is equals to Kg Cg over Kg plus Ks. What I just simply did there was factorization. I just factorized and brought out Cs. That's all. Now, let's go back to the question. I'm trying to derive out what I got. Now, they said write an expression to represent the overall resistance. Now, Kg and Ks is mass transfer coefficient and rate coefficient. Your normal K that you know from your minus R is equals to Kc. Rate constant. The Ks is the rate constant, while the Kg is mass transfer coefficient. Now when you say resistance is if, for example, this liquid is supposed to react with this particular solid normally, Now, on the surface of this solid catalyst or solid reactant that you have, there will be resistance for the fluid to react with the solid. Resistance means normally they do not want to react. They do not want to react so easily. Now, meanwhile, this Kg and Ks, Kg here means the ability for the gas to react. It's like saying the affinity of the gaseous reactant to react. And Ks is the ability for the solid particle to react. Now, if I'm saying I want the resistance, if this one is the ability for them to react, then their resistance will be 1 over kg. This is the resistance for the gaseous particle to react, and the resistance for the solid particle to react will be 1 over ks. That's just the simple meaning. If this one is the rate at which they react, this is the rate at which the solid particle reacts, ks. So the resistance for the solid particle not to react, that's the ability for it to prevent itself from reacting, will be 1 over ks, while for the gaseous particle will be 1 over kg. Now I have to look for a way to express this in terms of 1 over ks and 1 over kg, because they want us to express it in terms of resistance to reaction. Now if you come back here, if I do 1 over kg plus 1 over ks, okay, what do I get? I get LCM of kg ks, and I have ks plus kg. Now if you notice, it's almost looking like this, okay, kg, okay, kg is almost looking like this. Now before we do that, I want to say something. Now qs is equals to kscs, am I right? So this ks, sorry, so this becomes qs is equals to, just multiply ks times this cs that you got here, so I have ks kg over kg plus ks. There was a cg multiplying it outside here. Now if you agree with me, this value, the addition of the resistance, is almost looking like this. It's just that it's the inverse of this will give you this one you have here. It's almost looking the same, it's just that this one is the inverse of this. So to get my answer now, I can easily say that qs is equals to 1 over this. So I have 1 over ks plus 1 over kg, okay, dot cg. What I simply did was that I made the inverse of this, which will now become the exact same thing like this. Now if you look at this, now we've expressed our rate of reaction in terms of resistance to react. Now meanwhile, the overall resistance, okay, the overall resistance summation r, if this is the resistance for the solid to react and this is the resistance for the gas to react, then the overall resistance will be equals to 1 over ks plus 1 over kg. Okay, so I can now say that qs is equals to 1 over summation r dot cg. You can also call 1 over summation r k overall. Now looking at this expression, you've already derived out what you were asked to find. You were asked to write an expression for the overall resistance to reaction and define each term in your expression. Now the define part is simply saying qs is rate of reaction, okay, you say that ks is, kg is mass transfer coefficient, okay, mass transfer coefficient, then ks is rate transfer coefficient, okay, then cg is concentration of gas. Just simply, this one is overall resistance. Define your terms simply means that state what each term means, so that after deriving you can just state it out below. This is equals to this, this is equals to that. So that's just how you solve for this particular question. I'm going to go to the B part. Once you understand this first one, the B part becomes very easy. Now the B part is saying qg is equals to this, qs is equals to this. Now let's note this statement here. We're told that if the reaction is steady, from what we've learned, if the reaction is steady means qg is equals to qs, okay. Now if the reaction is steady, that means qg is equals to qs, okay. Now if qg is equals to qs, I have that, okay, to determine the rate of reaction, and they're asking you to find QS. Now, I'm looking for QS in this case. What do I have? I have Kg to be equals to 0.2. I have Ks to be equals to 6 times 10 raised to the power minus 2. I have my gas constant R to be equals to 0.0821. I have my pressure to be 1 atm, and I have my temperature to be 100 degrees Celsius. Convert it to Kelvin, you get 373 Kelvin. Okay, now I need my rate of reaction, which is QS. Let's express this out. So this becomes Kg into bracket Cg minus Cs is equals to Ks Cs. Now if you can remember what we did before, you will see that Cs becomes equals to Kg over Kg plus Ks dot Cg. This is what we got before, what I did earlier, this derivation here. Now after getting this, I have Kg, fine. I have Ks, okay. Now I need Cg. Now if you look at this question, all the parameters, the gas enters. So the P naught is for the gas, enters, that's why it's not. The T naught is for the gas. The gas constant R from the gas, you know that everything there is for the gas. Now to get the Cg, from your ideal gas law, we all know that PV is equals to nRT, okay. Now that means P is equals to N over V RT. I can now say that P is equals to CRT. Now I can say that C is equals to P over RT. What it simply means is that they gave me my P already, they gave me my R already, they gave me my T already. So from this I can now say that my C is equals to, I have 1 divided by 0.0821 divided by 373. You get your concentration to be 0.03265. Check your units, please be very careful about your units. Be very careful about your units. So you have mole per liter. I got the mole per liter from the gas constant. That's a very obvious thing. So this is equals to 1 over 0.0821 times 373. Now I already have my Cg, that's concentration of the gas. Now what do I need? That's all. I can easily get my Cs from here. And let's get our Cs. So Cs will be equals to Kg is 0.2 over, I have 0.2 plus 6 times 10 raised to the power minus 2 is 0.06 dot my Cg is 0.03265. Now if you do this on the calculator, you have 0.2 plus 0.06. So after getting 0.26, you have 0.2 divided by 0.26 times 0.03265. You have a final answer. Says please do confirm these answers with your calculators. 0.02512. Do not forget in mole per liter. Now after getting this, I can now say that my QS is equals to KSCS. Do not forget. And I have my Ks to be equals to, check your equation, they gave you Ks already, to be 6 times 10 raised to the power minus 2. So I have 0.06 times your Cs is 0.02512. Now I have my final answer to be 0.00151 mole per liter min. Now please confirm these answers with your calculator. The basic concept is for you to understand what is happening. Thank you very much, and I hope you understood what we did. If you have any questions, please contact me. Bye.